So good morning. Today's lesson that I have here is on classification and dissolve. And in this lesson, we're definitely going to talk about different ways that we classify data. We talked a little bit about dissolving in our previous class and what that looks like. Um, Specifically, we did an in-class exercise where we did buffers around a polyline. They intersected, and then we did a dissolve based on a field, or we dissolved all, or we dissolved none, and how that data looked differently. Hopefully you understand what an attribute table would look like when you do a dissolve. And we talked a little bit about, with dissolves, the state of Florida and all the islands that have a series of polygons, but if you highlight a single row in a state's attribute table for Florida, you would have a single record instead of hundreds of polygons there. And that would be an example of a dissolve. You would dissolve based on a field that would be the state. Maybe if you digitize the state of Florida and you had a whole bunch of polygons and you labeled each polygon by state FL maybe, we would then do a dissolve based on state, so all those polygons would be one. So we'll talk about dissolve briefly, but most of this lesson is on classification. And there's a series of tools where you will do different things with classification. But most of the time, all we're doing with classification is symbolizing maps and kind of trying to tell a story with maps using different colors and a way of breaking down information into a specific set of classes. So if you look on this concept map, there are different ways that we can break our data down. If we're talking about percent of population under the age of 5, we can have classifications where we have this equal interval. So a range from 3 to 6, 6 to 9, that range is a range of 3. We have 5 different classes, meaning 5 different colors, and they're broken up by those 3 percentage points. We can also do it a different way, which is quantile. There's a whole bunch of different ways, and what I would ask you to do is get on the in-class exercise or watch this video and pull up some data yourself and play around with this. I'm going to show you how we can kind of display data in different ways. There's a map called, not a map, there's a book called How to Lie with Maps, and a lot of what is talked about there is specific to classification, what we're going to talk about today. So there's quantile, where we can break these down. What that basically means is that each of these 5 classes, and we can specify how many classes we have, will have the equal number of actual colors. So there will be 1/5 of the polygons in here will be this color, 1/5 of the polygons will be that color, and moving away. And then we have defined interval where we can specify how we want to do these. So without any further ado, let's just get through this slideshow. Oh, the other thing we're going to show you is a Reclassify tool. So really we're showing you symbology here, not really a tool, but ways to symbolize our data. And then I'll show you 2 tools, the dissolve tool, which we showed briefly, as well as a raster reclassify tool. And the reclassify tool creates data. Dissolve tool will also create or modify your data. Okay, so here's the dissolve tool. We saw this before. We get the option to do different types of dissolves here. And also notice that we have this button here where we can create multi-part features. And if you want to create multi-part features, you can do that. That's kind of like if they're not connected. So the state of Florida has multi-parts. So you could do something along those lines. So in this particular case, these 3 polygons are all touching. But if we had another green item right here, and we said do a dissolve, and we don't have create multi-part features, this would be 1, and then the other small little spot right here would be a single record in the attribute table as well. But if we select that, then it would be a single record. So this is green and green. That could be a single row in an attribute table if we have create multi-part features selected. So the dissolve field, we can create, there's a bunch of options is the bottom line, and we need to think about when you're doing the dissolve. And I said last time the dissolve tool's kind of a way, sometimes we need it for our analysis, but sometimes it's just cleaning our data up and making sure that we have a nice data set that we can provide for other people to use for analysis, or to make sure we have quality data. Um, so we need to think through what we're trying to do. We'll also do dissolves, as I said before, if we have our shapefile and we bring it into a feature class or geodatabase, or we have a feature class, polygon, and we want to calculate area by dissolving, we can figure out the total amount of area associated with a particular I don't know, a particular record, particular feature, or particular area. You have in your workbook on page 45 another in-class exercise. I strongly suggest you get into your workbook and look at this. Just kind of look at this polygon, or the series of polygons, look at the IDs, look at what it's telling you to do here on how we're going to do our dissolves, and try and draw the polygon and talk about the number of records or rows that we would have in the resulting polygon. And then check your work on the file on the page afterwards, just to make sure that you're tracking. Again, this is a way that I can test you on, do you understand what's going on with dissolves? Okay, so data classification. Some information here. I'm going to let you just read through it, and then I'm going to show you some examples of doing data classification. We're going to break this down into a series of different examples. Natural breaks is often used. It's actually a scientific algorithm. It's called the Jinx function. A lot of people will use this as an optimization tool to try and optimize the natural places where the data has this break in values. You can kind of look at a histogram and see areas where, hey, there's a drop-off in this one window, and here's another area where we have not a lot of people, so let's put a break here for a long window, and then another break when we get this big jump. So you can do some things with a histogram, but this is actually an optimization formula used for these natural breaks. When you go into ArcGIS and you want to determine what type of intervals you want to use, you can actually get help and read word for word kind of what we have here for what equal intervals are, a defined interval is, what the quantiles are, right? And I've got an in-class exercise for you. If you go to the Y drive in EV398, the in-class exercise, there's a series of different map documents. You can just open the map document and you can practice doing some classification methods. You can kind of read this here and kind of work on it. But we're basically saying reclassify based on the population per square mile for 2010 data. I think it was in Iowa. I'm going to do something, I'm going to show you something different. Bringing in my ArcGIS. The first thing I will tell you is, always check your customized toolbar, customize extensions, make sure your extensions are turned on. And I don't like how this data looks. When I'm doing thematic mapping, I want an equal area type projection normally. So I can go into properties, my coordinate system, I can come up and say I want a not a geographic, but a projected coordinate system for North America. And then I can come in here and try and find something that I like. The equal area conic is great. Of course, I don't want Canada, so let's just look through here. Here's North America Albers equal area conic. It's always a good standby in my estimation for equal area mapping. I just think this is a prettier map, personally, anyway. The data that I have loaded here is from Esri's 2015 census data. It's available to you on the Z drive. If you go to Z drive look for Esri, and then there's a series of numbers after it. That's the census data associated with it. And this is just the county boundaries feature class. If we open the attribute table, it's a whole lot of data here. So this is the name of the county, the state that it's in, um, whites, blacks, I don't know what this is for sure, Asians, Hawaiian, Hispanic, etc. Males versus females, there's a lot of interesting information here. Um, One of the maps I like to make sometimes is, the percent of the population that are in a certain age, and then if I have it, I'm just scrolling through here, how many of those are, say, women, or percent women versus percent men. So the women know where they've got good odds of finding a man, and the men know where there's good places of finding women, if that's what you're into. However, it's pretty easy to do some other mapping here. So what I'm going to do is over here in the table of contents, I have ways of looking at and symbolizing my data. If I just right click and go into properties and go into symbology, I've got this listed as single symbol. What I'm going to do instead is I'm going to go into categories, and or I could do quantities, so where we have a color ramp. And in the color ramp I can come in and I can say, I want to do, let's say, well, let's do African Americans. Notice that there's 5 classes here, as is specified here, 5 classes. And low numbers are blue, high numbers are red. That kind of makes sense. We have labels. We can go in and we can modify some of this stuff if we want. But for now, we're just going to go ahead and apply this. And here's the resulting map. It actually is pretty aesthetically pleasing, in my estimation. You can change the color ramp if you want. I can show real quick. If I go in properties and just kind of, I can hit this drop down and I can do, something a little bit more like this. And I can flip my symbols. So now red is still the same way. It's a little bit different. I actually like the blue better personally. I think it stands out a little bit better. Or we can just do, other color ramps if we want. But so here's what we kind of originally had. And if we go back into this, the question is, how did we break down these 5 classes that we selected? And the answer is right here under classification. It shows you that we had 5 classes doing natural breaks, or the Jinx classification method. If we want a different one, we can hit the classification button here and hit this drop down, and we can do all of these other techniques. So if I said, I want quantile, and remember what I said with quantile, you can see our where the different breaks are. And you've got 48, 278, 1000, or 1736, etc. So pretty small ranges going to larger and larger ranges. And when you look at this map, we have a lot more color. That's what's expected, because in quantile we're going to have, in this case, 20% of each of the colors are going to be represented as far as the polygons. Some of them are smaller polygons. Some of them are bigger polygons. So total amount of red, blue, green might differ based on the size of each polygon, but the same number of polygons. If I did a selection, how many are in this class, it would be plus or minus 1 from all of these. And we can go in and change this to, say, let's do equal intervals. And it looks even more different. So if we go back and just say, let's go back, property, symbology, and let's get back into natural breaks. Let's go to, normally you don't want about more than 7 classes. It's just hard to delineate the different colors sometimes. And the color ramp got flipped. So we'll go back in, flip our color ramp. And this looks a lot like what we saw before. So how do we lie with maps? Well, we showed you one way to change the classifications. And there's different reasons to use different classifications. I mean, you should read the data or the information that I have out there um, on the PowerPoint and in the reading to say why should I use different techniques in portraying my data. But I really just want to show you ways to do this. Um, okay, so what's really going on here? Becomes an interesting question. Um, who would have thought that this is where the majority of African Americans live in our country? I know I normally sit here and say, this, I think of the South. I'm from Texas, was born in Alabama, lived in Florida, and I always felt like when I'm traveling around there, I see more African Americans than I do, say, well, certainly in the Midwest, but I don't feel it as much when I've been in California, Arizona, and New York, and I can't explain why on this map as to what's going on. Some of you guys may, and there's a reason behind it. Well, we're portraying our data where it's just a total number of African Americans. What if we said the total number of Africans divided by, and that's what normalization is, we're dividing it by our population in 2014. And let's then flip these symbols again. And this is going to be 55%. Red is going to be 55% to 86% of the population. The polygons that get the red classification is going to be 55% to 87% roughly. And now all of a sudden our data fits what I have envisioned when I'm traveling around. When I run into populated areas, because recognize that this is, a lot of the area in the United States is just open area. But when I'm in populated areas and I'm seeing a lot of people, the percentage is in this window where it's a higher percentage of African American. It's just an interesting, in my mind, cultural awareness piece and ways to represent our data. So to me, this is powerful. Compared to what I just had before I did the classification, it was kind of like, what's going on? This is more powerful, in my estimation, than what I saw before. And we can do similar things with Asians. There's plenty of other examples, but for the sake of time, I'm just going to leave that here for different ways of classifying data and portraying our data for you. The next thing we have is we've got some data also on the Y drive for a reclassify, and I'm going to actually show you how to do some of the reclassification in ArcGIS. We've got some data inside the map, and we are going to tell you basically to add the USMA digital elevation model and break the data down. So I've got the data open. Here's West Point. We've got a DEM underneath it. If I turn the West Point layer off, here's our elevation model. You can kind of see West Point shaded right there. Maybe you can't, depending on how this gets recorded. But we're going to try to use a reclassify tool. So if I do geoprocessing, search for tools, I say reclass, say reclassify using spatial analyst, and click on the tool opens. And you can always get tool help. It says reclassifies or changes the values in a raster. So the values I want to put in, I'm going to put in my input raster of my DEM. I know my values are between 2 and 444. And for some reason, this is taking longer than expected. Okay. So we've entered the data, and we've got a whole lot of information in this window that's reclassifying, that's a reclassification. And we can sit here saying, here's a range of the old values, and here's a range of the new values. So I can have a value of 1 through 9 and no data. Or I can go in and hit classify, and under this I've got 9 classes. They're using natural breaks. I can specify different ways that I want to do things. A lot of times what we'll do is we'll do 10 classes and we'll order them 1 through 9 or 1 through 10 or 0 through 9, 1 through 10, and we'll do some math with layers of raster, and we just kind of stack those grid cells on top of each other. And 9 or 10 would be really good attributes for some criteria, and 1, 2, 3 would be not so great. And as we have all these different layers stacked on top of each other, I can say add all the pixels up for each grid cell. And the overall value that's really high will be the best places to do something. Maybe it's the best areas to be driving a car, or maybe it's the best place to build a highway or something like that. Anyway, we can mess around with the different techniques to where we're going to draw these lines. I'm going to stick with natural breaks. I just like natural breaks personally. I've got 5 classes here this time. Let's go ahead and change that to, we'll do 10. We'll say OK. Now notice I have an output raster. So again, make sure you store this someplace where you want it, and how you are, file management becomes important if you're a GISer. We only have values here. If we had other fields, we can do it based on a different field. But I'm just going to run this tool, and you see down at the bottom, this tool's running. And it takes a little bit of time. And now we have our reclassified raster. If I zoom out, right here's the whole area, and I can move the West Point image right here. So this is what we were looking at. Here's the entire DEM and the different values of the raster. So if I zoom back in over here, and I turn off my RGB, you can kind of see, this is relatively low-lying areas, and this is kind of the Hudson River, and that's going to be about as low as we're going to go. So that's reclassifying a DEM. I wanted to show you some other things we can do with reclassification too while we're at it. These are track logs. So these are GPS tracks in the West Point area, I believe. And if we open up the GPS track logs and look at the attribute table, we can see a lot of information. We got index values, we've got the time, we've got a lat long and altitude, we've got the vertices and the speed that we were going. The bottom line is given some of this information and the points, we can calculate a lot of stuff. And certainly because we've got points in a row, we can sit there and say, given an elevation, the altitude, what's going on? Are we going uphill, downhill? What's the slope? We can do some calculations like that. There's some pretty easy to do, actually. We have a field manual on how to do that. But we can go in and we can say, I want to see the data based on speed. How fast were we going? And break that down for each of these individual kind of points and segments inside the line. How fast were we going at any given time? And this is 5 classes. Here's speed, or GPS quantile, 7 classes. Here's equal interval. And you can kind of see how we break this stuff down. So again, how you color code these and what you're saying, what you're trying to depict matters. So you got to think through, what's my color code? How do I want to symbolize my data? Things of this nature. Let's see, what else might I want to show you? I think that's it for today on classifying. Again, we have some exercises that you can mess around with. The data is available to you on the Y drive. I would encourage you to do that. I also encourage you to go in and look at these in-class exercises. Make sure you know how to do that. And let's let's look at our SharePoint for the course. We actually are kind of in a little bit of a hiatus on labs. So we just finished our georeferencing lab where we lined our rasters and different files where they line up in space correctly, so everything's overlaying properly. We're on lesson 21 right now, which was classification. And next we're going to do geospatial data quality. Geospatial data quality is important. One of the reasons why is GIS itself is important when you start talking about quantifiable information. So we can sit here and we can say, here's the areas that fit some criteria. But the accuracy associated with that is important. If you go tell your boss, hey sir, this is the right area to do whatever from a military standpoint, or if you're a businessman or a woman, and say this is where we should build a Starbucks coffee shop, is the example we've been using. How accurate is the information? That becomes a really important piece to GIS and remote sensing and all sorts of other things that we do with computers to look at environmental challenges, real-world spatial problems. We need some sort of an accuracy report and say, I am 90% confident that the data that I'm presenting to you is accurate, or it's accurate to the 90%, or whatever the information is. If it's at 50%, well, the data's worth something, but is it as good as some other data out there? So how do we check our work is what we're going to go into next time. I ask you to look at this material and even scan the workbook. How we do data quality tricks some people up. If you look at the workbook before you come to class, you'll be able to do the workbook, you'll understand, you can ask me some specific questions on how we do data quality. This material here is really important. It's going to definitely be tested on your WPR, your final exam. So I would spend some time on this workbook. Then we're going to get into geospatial analysis and modeling. That's the model builder stuff I was talking to you about. I'll give you some specific details on what we expect, and there's a problem set that'll be issued there as well. So you've got a problem set on geospatial data quality. You can get ahead of the curve by looking at the PowerPoint. Then we've got a problem set on modeling, but we're not on the computers until Lab 8, which is vector analysis. So if you find yourself with extra time, and you want, you could get started with Lab 8. But most importantly, I would say, make sure you get your problem set 4 and 5 done first. Okay? So we only have 2 labs left. We got vector analysis, raster analysis, and then we'll populate the SharePoint with lesson 29 and 30. We're going to give you probably a drop for 29 to get your raster lab done, and then for lesson 40 we'll do a T review and final course critique. But that's where we're at now in the class. I hope you guys have a great weekend and beat Air Force. Sold out crowd. I've got a lot of friends coming into town, and we're all excited for it. So have a great weekend, and we'll see you next time in class.